You ready? Okay.
Good afternoon, everybody. It's about past. So, evening then, troublemaker in the front row. What, I'll have to be more specific? So let's go ahead and get started. This is DNS operations, the second session of this IETF, because one wasn't really enough. We have the next hour for some assorted discussion. And you all know who everybody is. Benno, Tim is not with us in person, but I think is dialed in. And Warren Kamari is our area director, so let's treat him with plenty of respect. He's the one in the funny hat. If you don't know Warren, and also we want to say thanks to Paul Hoffman for doing our minutes. So the note well everybody has seen, but if you haven't actually read it, please do. Working group chairs were reminded this week, for instance, that this is something people really do need to pay attention to, even if you've seen it. Do make sure you've reviewed it and know what it means for you. Also, the IETF Code of Conduct. These are also maybe something you've heard 8 times this week, but still important, and we still expect people to abide by them. We take the Code of Conduct seriously. If you feel it's been violated, please reach out to the chairs or the IETF Ombuds team. And beyond the specific rules, we have a sort of overarching rule here. We work as individuals. Let's remember to be nice to each other. Usual IETF meeting tips. If you're here, welcome. We're glad to see you. Make sure you're using the Meet Echo on-site tool, which you can click on in the data tracker agenda. Use Meet Echo to join the mic queue, or you'll confuse the chairs. Keep your audio and video off if not using the on-site Meet Echo. For remote folks, we're happy you're here too. Make sure your audio and video are off unless you're chairing or presenting, and use of a headset is strongly recommended. So, and to our agenda, we have a couple of items that were brought for DNSOP to consider at the request of other working groups, and a couple of drafts to introduce that may eventually lead to work for DNSOP. There are 2 drafts that we were asked to mention. They're not being discussed in DNSOP today, but they do touch on DNS management, and the authors are seeking comment. So these are both in the data tracker, the domain connect document in regex, and the integration of DNS domain names draft. That it's not clear where its home will be, but the authors did upload it this week and are seeking comment. So we have the 464 customers side node recommendations that Tommy, I think, will be providing some overview and asking some questions. An update on the side meeting, the load balancing that I'll bet many of the people in this room were in, many more. Another new draft on client authentication recommendations for encrypted DNS. That does call out what could be an interoperability challenge among different implementations. So it may well need some work in DNSOP. And we have a presentation, time permitting, on a method to prevent zone walking in DNSSEC. So we can go ahead and is Tommy here? Okay, terrific.
Yeah, it's a problem. All right, thanks everyone. Hi, I'm Tommy Jensen. I unfortunately missed, I didn't create a great name for this, but we're gonna be talking about 7050, that's for sure. So for context, Jen and I are writing a draft in V6 ops that talks about when to enable CLAT, which uses DNS6.4 or can use DNS6.4 to discover an IPv6 translation prefix. When going through the different RFCs it depends on, we realized that RFC 7050, I'm not a fan of how it defines secure channel. And so it says it should communicate, the node that is doing the prefix discovery should communicate with a trusted DNS6.4 server or secure channel or use DNSSEC. And the definition of secure channel is there on the slide, which essentially boils down to use something like IPsec or link layer security, which is not very specific, not very helpful, and from what I can see, not very widely deployed, especially when we have, since this was published, DNS-specific standards for advertising encrypted DNS configuration and then using encrypted DNS, which I tease the next slide. I do that. And so RFC 9463 actually allows a network to directly advertise encrypted DNS server config using DHCP or router advertisements. And so why not just do that? And so that's the first part where I got the name from. And then in the presence of this, where if you can use this mechanism because you have a name to associate it with, there's no need for a DNSSEC-based mechanism. And so the other thing this proposed text does is rip that out. Now, I shared this with the mailing list, and the discussion that resulted wasn't quite what I expected. What actually happened was, why don't we just deprecate DNS6.4? And I got a lot of energetic responses on site here this week on that I was not expecting. So I was going to come here and ask, what people thought of this definition. Instead, what I'm going to start with is, do people think that we should update or deprecate this document? The group that created this was Behave, which has shut down. And so the chairs and the AD said that it should come here for consideration. So regardless of what that decision ends up being, I still think there's a separate discussion where it goes. But first, and this is the last slide, to the queue, should we deprecate DNS6.4? Should we update it like this or update it a different way or leave it alone?
Warren Kamari, could we go back to slide 3? I'm just wondering if we could be like creative in the reading of, for example, right? Like, for example, a link layer that uses encryption is do or dot or something. Like maybe it's already covered.
No. I mean, don't get me wrong. It's not like the OSI model is perfect, but calling TLS link layer is probably going to turn heads elsewhere. Oh, okay.
Tommy, we have MACsec,
We have what?
MACsec. You can have
Perfect,
encrypted
yeah.
Ethernet connectivity.
Don't see why not.
Jen Linkova, I guess you know my position on this. I think ideally I would like to see this disappear. If it cannot disappear, let's say, please don't use whatever was written there and use secure and always use secure communication. So, I mean, if we cannot deprecate it for some reason, I think we shall send a very strong message about not using RFC 7050 as it is. Not just recommend using something else, but clearly say don't do this.
So to clarify, something along the lines of what I put, but it changed the should to must and explained there's no out there.
Yeah, and maybe even must not do.
Okay.
Because, well, people are creative in readings.
Apparently.
Ben Schwartz. So this is a should, but we know you won't, right?
It is, yes.
Because almost nobody does either of these things.
Yeah.
Okay. Yeah. So I'm actually with Warren. That is that it says you should use a trusted server over a secure channel, and we have some secure channels that you could use, and okay, editorially we could now, if we are revising it, we could change the examples of good secure protocols, but it's not a normative change. So I'm not worried about that. But nobody does this. So like maybe our recommendations should reflect reality in some way.
Okay, so just if you could stay right there for a moment, do we want to write something that reflects reality or write something that we want people doing from now on?
I think telling people from now on you should use DNSSEC validating stub resolvers is like not a useful normative recommendation that we, should expect to get a lot of traction on.
Nor did I write that. I guess
I know,
what I
but
mean is
RFC 7050 appears to effectively say that.
it currently does, yes.
I mean, validating stub resolvers do exist, but
Sure.
not on any phone that I own, not on any computer that I own.
Sure.
Mark Andrews, the text there just said a secure channel. It doesn't prescribe what the secure channel is. It really doesn't. It says, for example. It does not go past that. It does not say you have to use anything. And the reason for this is the DNS 6.4 actually changes quad A records. So you cannot, if you've got a DNS 6.4 server, you're placing a lot more trust in it.
Mm.
Yeah, you've got to trust the quad A's that are being returned.
Because you can't use DNSSEC validation to
Because DNS 6.4 stuffs with
Yep.
broke DNSSEC, and I tried very hard to stop it when it was being produced. But yeah, and yes, DNS 6.4 should go. It should be made historic. It's not needed. It really was never needed.
Okay.
And NAT 6.4 was never needed either. We had when DNS 6.4 came out, we already had DS Lite. We had the way to deliver IPv4 from a V6 only network at that point. People
I think
people were scared that it was
should
new,
stay on topic.
but it existed.
Sadly, that ship has sailed.
Yeah, it's
a little while ago. Hi, David Skenazi. I'm a little disappointed in you, Tommy. You missed the obvious solution here.
What?
Clearly, the link layer is Mass Connect Ethernet. You run all your DNS 6.4 over that.
What was I thinking?
No, but I actually came here to make a more serious point. So some number of moons ago, while I worked at Apple, I implemented RFC 7050 because I was working on Happy Eyeballs, what eventually became the Happy Eyeballs v2 RFC, and sometimes stuff wasn't working. Because if you go back to when DNS 6.4 was written, the idea was, all right, we got the applications to update their code to IPv6. We don't have all the servers supporting IPv6, but if we just put a NAT 6.4 here and we do DNS 6.4, it'll just work. Turns out that was wrong. It didn't really just work, and there are plenty of reasons. So Section 7 of RFC 8305, which is Happy Eyeballs v2, has a whole list of things of pretty much how I shot my toes off one after the other with DNS 6.4, because like if you have a VPN or multiple networks, things just don't work. You can read it if you want the full details. But conceptually, the idea was there are cases where DNS 6.4 doesn't work for you, and you need to just use NAT 6.4 directly. Pretty much inside your Happy Eyeball stack, you do you create your v6 address out of the v4 address directly. And that means you don't even need to use the CLAT. It's pretty great. At the time when we wrote that RFC 7050 was the only way you could get the NAT 6.4 prefix. And by the way, it's a very inconvenient way to get a NAT 6.4 prefix. And so now that we have other ways, you can get it in RAs and various things, I don't see a use for this at all. So my take would be to deprecate 7050 and probably DNS 6.4. You still have a need for NAT 6.4, but if you have a way to get the NAT 6.4 prefix, just have your application do the synthesis. It'll solve the problem. And it also fixes DNSSEC, which I hear some people care about.
Lorenzo Coliti. Our 7050 implementation started off using IPv4.google.com, and it broke when we mistakenly announced the v6 Query record for that. So I agree that it's not a particularly good mechanism. The Android DNS resolver does do synthesis internally, but it can learn the prefix through 7050. I asked, as the author of the Pref64 RFC, I do think it would be nice if 7050 went away. I will point out that some mobile carriers do use it still, and they don't use the Pref64 option. I don't know how much pushback you'll get from them if you declare it historic. The other thing, though, I mean, which data link layer does not utilize data encryption technology? You know, I can tell you that cellular networks are encrypted. And it's sort of like, I think all links should use encrypting technology anyway. Like, you know, Wi-Fi is encrypted most of the time, so maybe we don't need to do anything, right? Because it's should, right? So you should already encrypt data link layer anyway, right?
If it's not clear already, what I'm allergic to is having an RFC that makes it sound like you have stuff to do when really we're all just doing the same thing. Like, we should be honest about either we're not going to do it and we should make it historic, deprecate it, whatever, or we should clarify it and say this is what this really means for poor implementers who come in to implement CLAT 10 years after their competitor, who shall remain nameless, and figure out what's actually happening.
You could always update 7050 to clarify that nowadays most links are encrypted and therefore it doesn't matter. Or I mean, or the other thing you could to point out is that if you're getting a DOT resolver,
Which would you prefer?
7050 needs to be very topologically closely related, you know, very close. So if the DOT resolver is further away and it's preferred of the plain text resolver, 7050 might even give you the wrong answer. So that's another thing to think of, right?
So Nick Baraglio with the SNet. So I would be in favor of deprecating this, and let me tell you why. One, there's a lot of moving pieces in the migration to v6 only from dual stack or from straight IPv4 only. Deprecating this would not preclude anything that already exists, but we have better mechanisms to do this that are already being deployed. What deprecating this would do would send a message that you should be doing this way because this is the modern way to do it. And the sooner that happens, the sooner we'll get people to stop deploying it in this manner. So it's really sort of hedging against doing it in a better way now rather than having to clean it up later. From an implementation, from an operator standpoint, that is.
Thank you. We have 2.5 minutes, 2 questions and 3 slides. So you can manage the time a little bit. Tommy, how do you want to do that?
I don't have any more slides, right? Or do you mean the next set?
Yeah, you have a question to the working group.
Or is this a discussion you needed?
Yeah.
This is the end. Yeah, this is the discussion
Okay,
for these.
but please
2
go ahead.
minutes. Yeah.
Yeah, so Warren Kamari, Google. What I originally got up to say was Ben Short said, like, nobody's doing this. But I think everybody's doing this, right? Like, if you're using NAT64 on this network, you're doing an encrypted link layer because the Wi-Fi is all encrypted. That's just a separate thing, right? I just wanted to correct Ben.
You're right. You're right. You're absolutely
actually,
right.
But I'm not saying I'm not saying we should keep DNS64 around. Just if we deprecate it, we should make it clear that, you know, this is the signal to move off it, not thou shalt not use it as of today.
And why we're yeah, that makes sense.
Yeah. John Linkova. First of all, Warren, in v6 ops, we already have a document which saying, yes, it would be highly desirable not to use DNS64 and instead use local synthesis and Pref64 and other mechanism. So we do have another mechanism instead of this. And I have had a discussion with people who said, yeah, we only implement 7050 because we don't have a use case. So sending a clear message that this is not recommended and being deprecated does not prevent all those mobile operators to still use it, but at least they will know that they're using some like outdated technology. So I'm definitely, and I actually came here to say, yeah, encrypted Ethernet doesn't give you anything because your DNS will be so far away. And we all know all other drawbacks of using 7050, like you can't use your third-party resolver unless you also implement 8880, which nobody does. So,
well, that's a clear working group signal.
Yeah.
Thank you, everyone.
Thank you very much. Yeah. Thank you.
The next deck as well.
We have Ben
Okay.
for the next.
Yeah, Ben is
Just check.
Thank you.
Ben Schwartz to offer an overview of what happened in the load balancing side meeting. Let me get the,
Okay. This is my clicker.
let me get.
Okay, we had a side meeting yesterday. About 60 people came, I think. We had presentations from myself, Shane, and Davey Song of, I think, China Mobile. And we had a lot of different ideas that, that came up in the course of that conversation. We had 90 minutes and a lot of things to talk about. So this is just a selection of some of the more memorable proposals that people thought through, of things that could be interesting to work on. There were also some concerns raised about whether there's something that's sufficiently useful that we can do here. And overall, I would say there was a lot of interest and discussion, but it's definitely not yet clear if there's essentially a scope that draws enough interest and has enough support to be able to move forward to something more concrete. So it did seem like everybody who talked about it in the room would be interested in having a place to continue that kind of discussion on this topic and keep looking for an opportunity to do something useful and concrete. So we intend to request an IETF hosted mailing list. Warren points out to me that we are going to need a name for this mailing list. So on the DNSOP list, please chime in with what you think the name of this mailing list for DNS-based load balancing, DNS-based traffic targeting, GSLB, as it's called in a lot of the literature.
You know, naming mailing lists is one of the really hard things we do around here.
But not at the microphone.
Thanks.
If anybody wants to make a comment about the side meeting, not related to the name of the mailing list, we have a little bit of time for that.
Wow.
Okay, seeing as I have a timer with 7 minutes on.
You don't have to.
He wants to talk about something else.
Do what you have to do.
I just want to mention that one of the very interesting questions that came up in the course of this conversation is, should we be thinking primarily about changes that essentially are internal to the operation of authoritative name servers, where we are essentially trying to improve the ability to operate those name servers in a way that is supported by standards? Or should we be looking at the protocols that are spoken between resolvers and authoritative name servers, or even all the way down to stubs and stub resolvers, through this whole stack, or maybe even further down the protocol chain into the clients that are making use of those DNS queries, and for example, linking somehow into the revised work that's happening on Happy Eyeballs. So there's a wide range of possibilities here, ranging from pretty narrow scopes to pretty enormous scopes. And I really hope that people will join our mailing list once we have it. I'll send it to DNSOP, of course, because I'd love to keep talking about that and see if we can find something really useful to do here.
All right. All right, and I think Tommy, you're back for the next one here.
Hey again. This time we're going to be talking about client authentication recommendations for encrypted DNS, thanks to my co-authors listed here. So for context, usually authenticating to an encrypted DNS server is a bad thing in that you don't want to de-anonymize yourself, enable user tracking, etc. But The enterprise use case is one that's convenient to point at, but in general, when the same entity owns both endpoints, a DNS server and a DNS client, say on an operating system or in a managed browser, and wants to say, I only want myself to be able to connect to the server, authentication starts to come into play. And this is something that's becoming more common, we see in the field where we have people working from home, not having a network edge, where they still need to connect to a work-provided resolver or a trusted resolver that may not be publicly available, even though it's publicly routable, if I can abuse the word available there for a bit. Achieving this otherwise means you have to set up tunneling for the server. I know the word mask came up earlier, but wouldn't it be great if DNS could handle it itself, seeing as it already uses TLS? So this draft was written to see if we could come up with a consensus for different implementers of both DNS recursive resolvers and DNS stub resolvers in various products on best practices that we stand a chance of being able to play with one another instead of having walled gardens where from this vendor it works this way and from this vendor it works another. As well as to codify when it's appropriate, because clearly when you shouldn't do it, you absolutely shouldn't do it. And so we didn't want to just write a draft that says you should auth sometimes. In a nutshell, it goes through and says that use of client authentication with encrypted DNS ought to be restricted to when the server gates access to a specific set of clients and those clients are pre-configured, i.e. the client was expecting this, not the server challenged it out of the blue, because that'd be a great way to leak identity. And then optionally, maybe the server needs to treat clients differently, but that's a bit of nuance. We can probably spend a lot of time debating everything else first. Where in all other cases, you shouldn't be doing this for various reasons. If you have servers that offer different functionalities, they can do that at different endpoints. It doesn't mean that they need to authenticate clients and then sort them in that regard. The following requirements were listed to help guide a selection in what we would consider to be best practice for use of authentication with encrypted DNS. We wanted something that could be amortized over connections, because again, in the case where you have a pre-existing out-of-band relationship with the resolver, privacy of queries is a little less of a concern, clearly, if you're authenticating. So long-running connections amortize the cost of that. Use of existing standards, here we are, right? And reusable across encrypted DNS protocols, because there are 3 TLS-based ones that have come out in recent years, and we don't want to have different practices or different solutions based on which protocol you're using. And then finally, not having the human click-through factor, right? Because some forms of auth do proof of presence or other human-centric things that we don't believe are appropriate for this particular use case. Working group opinions welcome. So, spoiler alert, MTLS is what the 00 recommends for various reasons. Listed out, I won't read through all of them, some of the alternatives that the draft explicitly calls out there and why they weren't selected. For a number of things, being HTTP specific ruled them out, because sure, that works great for DNS over HTTPS, but DNS over TLS, DNS over QUIC ought to be supported as well, and selections in those protocols shouldn't dictate which vendors you get to work with. And then, yeah. So the next steps, this does not have a super obvious home. So thank you to the DNSOP chairs for hosting us for this discussion. Very curious to see what people think and letting us know if this belongs in the IETF, if so, where it belongs, and do you agree, how would you like to see it changed?
Warren Kamari, Google. Could you go back to slide 4, I think? Yeah, that one. So I use Comcast at home. Their resolvers are only available to a specific set of clients, and they can say, please fill in this form in order to get access to it. Now, they're sort of allowed to do this. Basically, how do you prevent this being, our resolver is only available to to our ISP customers, therefore we're allowed to do this?
Great question. So, setting aside whether we got it correct in the text or not, the spirit of this being that in that scenario, you are the admin of your device, Comcast is the admin of the server. You're not equal. It's not appropriate. Like that Comcast asks you to configure that is bad, but I guess, I would definitely be open to calling out that kind of thing very explicitly, but that's the spirit answer.
Yeah, I get the spirit. I'm trying to figure out how we do the wording to make it so that, we can communicate the spirit. And the other thing is, why not do this in ADD? It feels very ADD-ish.
So ADD,
I like it, but yeah.
Okay. ADD is chartered for discovering server properties. ...
So Tobias Sievig, MPI Inf. Just reinforcing Warren's point and like making very explicit that the connection between the different statements for when and when not something should or should not or must not be done, like the connection, whether it's an or, XOR, and must be very explicit.
Absolutely, for certain. And we did our best to take that, but I hear you. And so if this is work that comes here, for example, we would more than welcome PRs to help make that explicit, because yes, both sides, we don't want to be over-inclusive on this in any way in terms of when you should.
Wes Hardica, USC ISI and the ICANN board, not speaking for the ICANN board. I'm required to say that, sorry. So I love the idea of providing this guidance. I think it's actually super critical. The one issue that I have is sort of tailing on to what Warren started. In the end, knowing whether or not you expect to need to authenticate to something always will eventually fall down to the user in a bunch of cases. And we've already proven that users cannot make that sort of decision, let alone it becomes very difficult. I mean, Warren's Comcast router might know that it needs to authenticate, but not all the devices within Warren's house, let alone the guests that come visit Warren's house. It's just not possible. So I don't know how you're going to resolve that particular issue, but the rest of it all sounds great.
Quick question. Do you think that putting verbiage that's explicit to, say, enterprise or some other description of use case would be helpful, harmful, useless?
Yeah, so if you can spell it out to say managed devices, yes, that's probably the right, thank you, Warren, that's probably the right way to you need to spell it out very explicitly. These types of applications will always or never, expect to do authentication.
Okay.
Ben Schwartz, I think I agree with like all of the substantive content of this draft and am like completely horrified by everything else about it. So like I have to admit I can't quite put my finger on it. I did try to send an email explaining, but basically I think the draft is kind of upside down. Like we at the IETF build protocol components. These protocol components can work together in various ways. We are not the protocol police. We do not tell people, we are not empowered to tell people that these two things that work together can't be used together. What we can do, and that to me is what's happening here, part of what's happening here. And conversely, we're making recommendations. We're telling people out of the universe of things that can fit together, you have to use this pair. Use TLS authentication with DOE and not any of the other potential things that could work. And that also seems very strange to me. The thing that makes sense to me here is to say, so you've decided to use MTLS to authenticate your DNS server. Here are some things you could think about. Here are the privacy implications that creates. If those privacy implications aren't a good match for your use case, then like you're in danger. And like, here are the performance implications. Here are the like client user experience implications. Here are the reliability implications. I think that's a bunch of valuable stuff that we can do. But telling people like MTLS, that's the way that you should authenticate when like lots of other things exist and more things might exist in the future, like that seems very weird to me. I'll give you an example. In the Privacy Pass working group, a few people just came forward with and also other working groups with a proposal called EAP PPT. It's EAP, instead of EAP TLS to authenticate to Wi-Fi, it's using Privacy Pass to authenticate to Wi-Fi. Well, if you can use Privacy Pass to authenticate to Wi-Fi, then I think you could probably use Privacy Pass to authenticate to a DNS server. And I don't think that we here should be in the business of saying, nope, that is not how it's done. Like, I don't know, we've got these components. If they work together, then they could be used together. If that has some like non-trivial consequence, then we should document it. We should be very clear about it. But the normative language and recommendation, like MTLS is the way, that I don't know, very strange to me.
Fair point. I want to tease apart that we definitely do make a recommendation. What we do not do is say, and shouldn't do anything else. I think, honestly, we have a lot of overlap in that we want this to be able to explain what the trade-offs are in different authentication mechanisms and why you may or may not want to choose them. Would love to talk with you more offline about that.
Yeah, sorry. I don't actually think you need to mention any other authentication mechanism. I think it's sufficient to say, like, MTLS can be, like, it does work with these things. Let's talk about the properties that creates. I don't see any need to, like, attempt to, like, do a survey of all the different possible ways that you could solve this problem.
Interesting.
That's
okay.
That doesn't seem like it needs to be in scope.
Okay, so that was something we were hoping would be illustrative of cases. So that's good feedback. Thank you.
Jim Reid speaking for myself, of course. I think people are sort of comments on the microphone are trying to delve too much into the detail of the draft in front of you just now, almost like they're trying to refine the draft before it's been adopted. I think this is a great piece of work that you've done so far. Implement details and other nits and stuff need to be fixed out. That can only be resolved once we actually adopt the document and have a working group work on it. And in my opinion, it should be adopted, and it should be adopted here because there doesn't seem to be anywhere else in the IETF that would be the right home for it. So by all means, please pick up this piece of work and get on with it. And we can have a discussion then about whether MTLS or other kind of authentication schemes could or couldn't be used. Just get this thing picked up and worked on because it needs to be done. Thank you.
Thank you.
I agree with Jim. Yeah, I don't know. not yet, Jim. So I think this document, the text needs a bit of work, and I volunteered to help, and I think it's a good document. I think the two important points are, for me, that interop is important here. We have lots of different ways to authenticate. It's annoying if everybody uses a different way arbitrarily without having a good reason. There should be some guidance as to how you do this. And I think the other area that is actually called out quite well in the draft right now is that getting this wrong, having like bring your own device attached to a corporate network, suddenly revealing things to external systems where you expect some privacy, but in fact you're not getting any because you've got a employer profile installed, that's terrible. And we should be defending people's privacy. So I think it sounds a bit weird to say, we're going to talk about entirely a corporate use case where you have no privacy because you already signed it away when you joined the company and got paid. But what we're actually doing is defending the security of users using those devices on other networks or in other contexts or with other applications. And I think that's what's really important. If we didn't do that, then the chances are privacy is going to leak everywhere. And all of these things that ironically are precisely intended to give users privacy are going to be silently leaking things when they shouldn't. And that's bad. That's why this document is also important, I think.
Thank you.
Jessica Kronitsky, Microsoft. I'm one of the co-authors on this draft. And I just want to say thank you to both the energy and the hate of the way it's worded, because I think that we need a lot of help and eyes on how to strike the right balance. And I really agree with Joe and everything he just said. I guess back to something that Ben Schwartz said about we shouldn't say should, we should say maybe something like may, and here's why and when and what the properties of that are. I actually like that idea a lot. I think when I saw your email on the mailing list, I was thinking, oh, we're going to have to now enumerate all of the different things that could be used and when they should and should not. And that felt like maybe a bit too much, but also maybe could be useful, but then it would require a lot more changes down the line. But just to reinforce that the spirit of this is interoperability for those use cases where it does make sense. And yeah, hi and thank you.
Eric Nygren, Akamai. Yeah, thanks for pulling this together. I mostly responding to what Ben's comments. I think this is really valuable and would be valuable to have something that is giving a concrete recommendation as to enable better vendor interop, and so that operating system vendors can build things like this directly and have the hooks for it rather than having 12 different ways to do it. I also think it would be really useful to have this to also warn people about the sharp edges around things like don't use client certs if you're using TLS 1.2 without renegotiations. It's like a kind of obvious thing, but so many people forget that or don't realize that having something that really calls out the risks of doing it wrong would be valuable.
Good point, because that's obvious to us.
Q myself, MPI and enthusiast of being utterly horrified by documents. Echoing what Ben said, I think this makes a wonderful informational document if it's presented as, if you are doing authentication via MTLS, here are all the things here are the problems we've thought through, so you don't have to find the problems yourself. I may have very good reasons in my environment for doing DNS over HTTP and using the authorization header or something. I'm not saying I do, I'm just saying as a hypothetical, that's possible. But having the document that says we have thought through using MTLS for client authentication and here's all the problems we found and solutions for them really incentivizes people to go, okay, let's do that because someone's already done the hard work.
Makes sense. Thank you.
So Warren Kamari, Google, no hats. So, seeing as when we talk about things that horrify us, the whole idea of a corporate resolver is kind of terrifying to me. Like split DNS, I think is evil and should go away. I realize that's never going to happen though. I think much of the point of the IETF is for interoperability. So I think it's useful for us to have sort of the way you should do this. Right? And kind of disagreeing with Ben's, you could just list one way. If you want to interoperate between a client and a server, specifying this is the way we expect it to work seems good. Now, with the serious AD hat, if people think that it should be done here, I'm going to have to try and justify that to the rest of the IESG. And it's not entirely clear to me that it fits in the charter. So it might be good if we had something like a poll where we said, you know, who thinks this should be done here? Who thinks this should be done elsewhere? Just to give me some more ammunition when people are like, why don't you do it in TLS, LAMPS, ADD, deprive?
Okay. You want to poll now? Yeah, I can. Yeah. I just call it poll. No title, other than poll.
Oh, well.
There's no question. The question was, okay.
Okay, let's
I have an
do.
ID explaining what the question is.
Yeah. I was thinking the question is, do you think we should do it in DNSOP? If so, click yes. Do you think it should be done elsewhere? Click no.
Okay, that works.
The number of no opinions is interesting. Yes.
Hey, it's in our charter.
What
do you think?
So even between yes and no. Yeah.
Interesting.
Yep. Yeah. But again, this is just only input for Warren. Yeah. Ammunition for interesting.
Yeah,
We would like to hear how it goes.
Thanks, everyone.
Thank you.
Thank you.
So our next.
Yeah, but you have to close.
Oh, okay. She wants to. All right, I'm not.
Okay, so next is a remote presentation. Right. Okay. Right. That's something. It's not on my screen anymore. The poll. Thanks.
Learn something every day.
Yeah.
Hello, everyone can hear me?
Hi. Yeah, I can hear you loud and clear. You
Okay.
want?
Sorry, go ahead.
Yeah, you want to run the slides or shall I do that?
Yes, please, if I can get the control.
Yeah, you can request control.
I'm just figuring out how to request the control. If
Okay, I can do that by hand. Right. So now you should be able. Oh, sorry. Now you should be able to run the slides.
Awesome. Yep, I'm
Excellent.
able to. All right. Well, hi everyone. My name is Fatima Banatwala, and I am from ESNet, and this is the draft for zone hopping. Supposed to be very informational draft. So, and it's only 15 minutes. So it says I have 16 slides, but I might just hop quickly to the slide that actually matters the most. So, not wasting too much time on what and why DNSSEC is. Probably everyone knows the motivation behind it. And the important part here is the concept of denial of existence. So DNSSEC introduced this new record NSEC for actually authenticating the negative responses for the overall completeness of DNS authentication. So as an example, if you guys are familiar with DNSSEC, this is what NSEC looks like, that every owner name in the zone file would have an NSEC that will point to the next available owner name in lexical order. With that, I think the biggest challenge with the NSEC records right now is zone walking. It has been a long-standing problem ever since DNSSEC was introduced. So quickly, what zone walking is, since NSEC actually has the information about the owner name and the next name, anyone intentionally can query the domain names that are non-existent and can easily walk through the whole domain. And there are tools available out there that are free, open source, that everyone can use. And if they can find a DNSSEC enabled server, they can actually have a complete zone file transfer. So that is kind of like a huge problem for information leakage of the overall domain contents of a DNS server. So currently available solutions, NSEC 3 was introduced in RFC 5155. All it says is instead of revealing the plain text owner name and next name, we are going to hash it, and then we will provide the hashes so that it's not like the clear text enumeration of the zone file. But the problem with that is there was a talk in Black Hat, I think in 2018, where they were actually able to show that even if it's the hash domains, they can be easily dumped. And then if you can crack offline, there was like a success rate of 88% because the domain names are pretty standard format. So it was, again, not very effective solution. And after that, there was RFC 4470 that actually introduced the concept of minimally covering the NSEC records and the online signing. What it does is it actually is showing the concept that we don't have to be truthful for every negative response. What we can do is whatever queue name is asked by the client, and if it is non-existent, we are just going to encapsulate, and we are going to on the fly create a new NSEC record with the owner name and the next name that will actually fall that will actually encapsulate the non-existent query name, and then we'll respond with that NSEC record. So with that, there were two implementations. One was the NSEC 3 white lies, and then the second one was black lies. I think most of the people are very familiar with black lies because Cloudflare and Amazon usually uses black lies to kind of like isolate the information that is being leaked. So for NSEC 3 white lies, it's pretty standard. They say that we are just going to spin up the create the new n-sector records with the fake hashes, which will be like the hash of the QName that is asked -1 and the hash of the QName that is asked +1. And that record will be our new n-sec3 record that we are going to sign online on the fly, and then we'll respond it back with that signed n-sec record. With the black lies, they said that we are not going to use the nx domain as a negative answer. Rather, we are going to use a different negative response called no data. And whatever QName is asked that does not exist on the server, we are just going to create a new nsec type record for that QName so that the QName exists, but the type is nsec. So anytime a non-existent domain is queried, we are just going to send it over a no data response, and then we will just sign that record. So if you're doing a zone walking on a black lies enabled server, all the responses you get is whatever you're querying for. All the responses will be having that query name and then /000 in front of it as the next name. Okay, quite some of the limitations for the white lies and black lies. First of all, they're online signing methods. So the signing happens on the fly. That means the private key needs to be residing on the server that is actually sending back those replies. And the problem with that is those servers are internet accessible. So if there is any kind of compromise to that server, the private key gets leaked and the whole zone is compromised. Again, generating nsec signatures on the fly is computationally expensive and indirectly makes the server vulnerable to the DOS attacks. In fact, there was a very recent blog post on the Amazon Route 53 website where they actually addressed that problem that if we encounter a pattern of zone walking, we are going to throttle the DNS request to your endpoint, and that might result in the DNS querying timing out. That was an indirect DDoS or DOS attack on the server. Okay, so the draft proposes the new solution called zone hopping. It's basically a hybrid approach where we are trying to say that we don't need the authenticated denial of existence the response for the QNames that we don't care about. So it's like for positive responses, we will have authenticated DNSSEC responses, like with the signed RRSig for every record. But for the negative responses, we will just treat them as standard DNS, which means like we will just have a standard DNS response without caring too much about the authenticated denial of existence protection. So basically splitting the, and it actually allows the user or allows the admin to split between the domains that they find critical and has to have an authenticated denial of existence protection versus the domains that are non-important, sensitive, private, for which there will be no NSEC records. So something like that, before zone hopping, it will be like a sequential chain of NSEC records. But after zone walking, all you do is whatever whatever QNames you want to protect against DOE, you will only have NSEC records for those domains, and then delete the NSEC records for the domains that you do not want to get discovered by the zone walking process. This is just like we were doing the LDNS on the godpcap.com. So the before result is it will show all the domains. The after result will be it will not show the domains that does not have NSEC records. So it kind of like does not leak that information. But for those domains that are still there but don't have an NSEC record, someone can actually query that domain if they know that domain exists, and then the response will be like the proper validated response from the name server. It's just like this solution is intended to provide the spectrum of the solutions in the current chain of solutions. And since this approach is more closely related to standard DNS, all it will do is it will provide the integrity of the records by signing the POS responses, but it will have same kind of like limitations that standard DNS has for the negative responses. And the last thing that I want to point out is it becomes more important to prevent the zone enumeration for IPv6 only or IPv6 transitions, because the whole point of IPv6 is to one of the important points is to that it is not discoverable easily by scanning. But if there is a DNSSEC enabled server that hosts IPv6 addresses, then all someone has to do is just to dump the zone file and look for the quad A records, and it will know all the important IPs that a domain is hosting on their DNS server. And then that can be a target list or hit list for the services to go after. The one important thing I want to note here is the aggressive use of DNSSEC validated cache. So this solution would not work if there is an aggressive negative cache implemented, because of course, if you have an NSEG from A to C, and if it gets cached, then all the domains between A to C will get bypassed, because that is the response you're going to get back from the resolver if that's cached. But this solution has to be implemented with the traditional, like the standard DNS negative responses. That means the RFC 2308. That mentions that how negative caching of DNS queries should be done by matching the queue name and the queue type and the queue class, depending on which of the negative response is getting returned. So with that, I think I should just, there are a lot of questions, so I can just end my talk and then we can start the comments and discussions.
Okay, thank you very much. We have a nice queue of people that give feedback. So I know we're in a very nice group, DNSOP working group. So
It's Joe Abley. So I put my hand up early to come up and say aggressive NSEC caching, but you've already got that on the slide. But unfortunately, I think this is not an if the resolver is using; it's more like a when these days. So I mean, I like the way you've thought around the problem, but I think in practice, what you've done is stop zone walking, but you've also kind of stopped resolution of the names you actually care about. So I think, thinking around it and thinking putting a 0 TTL on the NSEC is an idea, but TTLs that are that low are rarely honored in resolvers. So I think it's a nice idea, but I don't think it would actually work. So I would, don't trust me on it. I would encourage you to actually try it and actually find out whether these concerns are real or not. But I think you should be prepared that they might be.
Oh, yeah, thank you. This is the first time there's a very scratch draft, so I'm here all ears for the feedback and comments on what are the drawbacks for the solution so that we can straighten them out and then see if that works. So thank you for the comment.
Hi, hi, this is Andre at IC. Welcome to the IETF. That said, and I hate to do that to you since this is your first time presenting. This is a horrible idea, and I said this with the implementer's hat. So aggressive use of the DNSSEC is being deployed by the resolvers. It's on by default, and actually, I think you would, if you like, the better solution would be even just return serfail instead of NSEC records, because that wouldn't break so many things.
So,
and,
sorry.
Well, let me finish one more thing about the deployment. So the DNS deployment has a long tail. So if we, right now, even if you convince all the implementers to implement this, it will take years and years to actually have them all fix the aggressive use of the NSEC. So this is not going to work even if you convince the implementers. And I'm saying that as a by9 head of the development, we are not going to implement this. Okay.
Yeah, that's good feedback. We were actually, we were actually thinking of server fail versus NSEC record, but that's the problem, like to have a hybrid solution where the positive responses will be DNSSEC, but the negative responses can be actual standard DNS. It's not supported right now in DNSSEC. So that's why we came up with, if NSEC is all is required for a negative response, then we are just going to bypass the whole zone and then just have a public NSEC with the 0 TTL so that it doesn't kind of like DOS the whole domain.
Hi, Evan Hunt, ISC. I'm going to make the same remark that I made when NSEC 5 was presented. I believe that there is an error on the very first slide where zone walking is identified as a problem. Zone walking is not a problem. The information that can be obtained by zone walking can be obtained other ways, passive DNS is a thing. If your zone is online, you have to assume that every query name in the zone has already been made public. So there's no attack that can be made against your organization with zone walking that could not be made against your organization without zone walking. The reason we had to solve the problem of zone walking was political. Nobody was willing to deploy DNSSEC without something like NSEC3. So we had to invent NSEC3 so that we could deploy DNSSEC. Now that DNSSEC is deployed, we don't need to invent another solution. It's been solved. It's not that this is a bad idea. I'm not saying that it isn't. I haven't thought about it in great detail. I just think that it's kind of a waste of working group time to continue talking about solutions to a problem that isn't really a problem.
Thank you. Yeah, we considered that, and I have few slides that shows that passive DNS can result in you cannot retrieve all the domain information from passive DNS, and there are a lot of limitations for passive DNS anyways. So I don't know. We did that study actually to compare the results, and you can see that we create quite a lot of domains, and then we found out that the overall passive DNS coverage for those domains was just 40% versus 100% from the zone walking. So.
Okay, and we've got one final comment in the queue, and then.
QMySL, MPI-Inf. Evan has effectively said what I was already intending to say, but just to reiterate it in slightly clearer words, there is no such thing as a sensitive DNS name. The DNS is public, deal with it.
Well, thank you for the comments. It is known fact that DNS is public, but again, when we did zone walking on the domains that have DNS enabled, most of the time we found out and we encountered the DNS names that were public, but they shouldn't be public. So I think even though everyone knows DNS is not sensitive, but I don't think so people who are implementing DNSSEC realizes that it's getting leaked out.
Thanks, everyone. And thank you especially to the presenter for being willing to get up in front of this room. It's intimidating. But I think that's the end of our agenda for today and for IETF 120. Do you have anything to add?
No, thank you all. And if you have additional comments, please post them on the mailing list for any presentation, including the last one, so we can help researchers also to understand the DNS and the problems in the DNS. Thank you all.